So one of the things about Rust is if you read the Rust language website, it will talk about fearless concurrency and other stuff in their main kind of blurb. And it's kind of true. It's like what I found programming in Rust is that you can do concurrency, multi-threading, very simply. But many modern languages like Go do this as well, very well. So in terms of when we talk about concurrency, we talk about threads and also the message passing between them and sharing state between threads or execution cycles, and then we also have async await. So I'll go through all of these a little bit. If you have any questions along the way, just ask. So the Rust started quite some years ago, and its threading model evolved a lot. And there's actually a very interesting video which I'll link to, where a guy goes through the history of the threading model in Rust and why they ended up going with what's called OS threads. So threads in Rust are pretty much just using the threads from the operating system. Whereas they experimented with something called green threads, but the biggest issue with green threads is it wasn't very interoperable with C, and Rust will always be interoperable with C. The problem with OS threads is that they take a lot of system resources. You can have finance. You're fine having a few threads, but if you're having thousands of threads, that would be like take up, especially in terms of memory, it'll take a lot of memory. So I'm just going to go through this quickly and just show you some examples of how it's done in Rust. So creating a thread, you can import the standard library has a thread module, and which you import, and it's quite easy. This is just you spawn your thread. In this particular case, it's spawned inside a closure, which is, you think of it as a function. This thread will print something out, sleep for a short while, print something out again, and here it will come down here, and this join function will wait for that handle to finish, and then it will unwrap. And in this case, unwrap means if there are any errors, crash. In general, you shouldn't really use unwrap in production code. But what it means is inside this handle and join, that will contain any errors until you run the unwrap function. So it's pretty easy to spin up a thread, but then it becomes a bit harder. Like the Rust programming paradigm, you're not allowed to share state, and so you're not allowed to share state between the main thread and the thread which you're going to execute. So a program like this, the compiler will actually complain to you. It will complain. Here we go. It does, normally you have color, and so this is a screenshot of the error message which you get. Normally you'd have it in color, but I didn't do it. I must have done it in black and white. So what you'll see here is essentially this value v is borrowed by the thread, and it doesn't know how long it will live for. So it's basically saying that here you're using this value v, but it's actually in a different thread. So you're not allowed to pass state like this across threads. But there are different ways of doing that. So in this case, we have the move. So if you put a move in front of this closure, it will move the variable v from this thread from the main thread into this thread here. So what that means is if you tried accessing v down here, you wouldn't be able to access it anymore. It's been moved. So if you want to create a thread, you can move your objects into that other thread. But if you want to communicate between threads, there are different ways of doing that. One of the idiomatic ways of doing that is to use the Multiproducer single consumer messaging protocol, which is, I think, this similar way as what Go does it, and many other languages. And so in that case, you communicate using channels. So you create one or more TX channels, which are transmit. And you can only have, in this case, only one consumer, which is the receiver. There are some crates which will allow you to do multiproducer, multi-consumer as well. But I don't believe that's in the standard library. Does anybody know? Yep.
I think from what I've heard, I could be wrong, but that's more or less considered to be not the thing you're using more cross-beam, which has a lot of channels, and it's considered to be sort of the one you should go to.
Yeah.
That's what I've heard, but
yeah.
They can't get rid of it because it's in the main library.
Yeah.
But,
Yeah.
It's sort of considered to be not the correct one to use.
Okay, yeah. Yeah, I actually haven't used threads in Rust for quite some time. So this was how it was a year ago, and it works quite well.
Oh, it works. It's just not considered as good.
Yeah. And so, I mean, in this case again, we're moving the TX into the spread, and then what we can do here is we will send this value from this thread back to this thread here, and so this actually gets moved. I believe it gets moved. Actually, I'm not quite sure. Does someone know the answer?
Just additional question on top of that. So you move TX but not RX. What happens to RX?
So RX is. So what we're doing is we're transmitting a message from this thread here, and we're receiving it in this message here, and so RX is down here.
But move doesn't declare which thing we move it. How does it know we move it to TX, not RX?
Function closes over will be moved.
Yeah. So anything which any value which was in here and is being used in here gets moved into that thread. Yeah, it's
so
not.
It's like
Yeah, but then the ones which haven't obviously just stick around where they are.
Yeah, and then again, what we're doing is we're receiving it here, and that's how you pass a message from one thread to another. And then you can get more complex as well. So if you want to have multiple transmitters, you can do that as well. So you have to clone the transmitter, the one transmitter. So, just the TX. So we create a TX1, which is a clone of the original, and here we can use TX1 to send things to the main thread, and here we'll use TX to send that to the main thread as well. And then over here, in the main thread, we'll have to go through all the RXs, and then we can print those out.
I have a question regarding the previous. So you were asking the question if it's being passed, like if it's being borrowed or it's just a read, right? If it's able to read the volume, just read only on the after it gets off the thread, so you're getting let receive.
Yeah.
So what is happening there? Is it able to mutate it? Like, can you borrow it?
Yeah. So here you actually own it again. So,
so it's ownership, okay.
yeah. So what will happen is, the thing is, I'm not quite sure, and maybe someone else can answer, is when this actually gets sent from here, is this a copy? No, I think it actually gets moved. It will actually get, it will get moved from this thread to this thread. And so the beauty about that is most messaging things with other languages is that actually make a copy of that message and copy that message across.
But it's not a copy, it's actually moved.
It's a move, yeah.
So by waiting on the receive, you're basically synchronizing your code, or am I not?
Yeah.
So yeah, the receive is just going to sit there and wait till
It waits there until until one message is coming.
otherwise.
Yeah.
It's written intelligently, so it doesn't actually
But-
stuff.
That's what I was asking. So after it hits that line, the code is going to be waiting until
Yeah,
it receives.
until it comes through on that.
So you're synchronizing your code in this script.
Yeah.
Yeah. Okay.
Yeah, it's blocking. But what you can do, you can also query. You can query, is there a message available? So I think it has. I can't remember what you do. And so what that means is you can go, is there a message? Yes, then I'll receive it now. Otherwise, continue doing my code. Running my code. So you don't, in this particular case, it's blocking, but you don't always have to block.
Mm.
Yeah. Does that answer your questions?
Yes.
Yeah.
Thank you so much.
Any other questions? So same with this example here is you can create multiple transmitters. You just need to use this clone. And I'm not quite sure if these other crates implement a more ergonomic way of doing that instead of having to explicitly call clone. I'll skip that one. So the other thing of sharing state is a mutex, and a mutex will is called short for mutual exclusion, and what it does is when you have a variable in one thread and a variable in another, you've got a variable in one thread and you want to access it from another. So what you do is you lock that variable and you put a mutex around it such that you can only access it when it's locked, and then only one thread can write to it at a time. And Rust has that in the standard library under sync mutex. And so in this example, we create a counter mutex, and here we go and create 10 threads, and then we count for every thread. We will lock the counter and unwrap, and then what we can do, that is now locked for this whole block. This num is locked for that whole block, and so at the end of the block, or before the end of the block, we increment num, and then we get to the end of the block, and the lock is automatically released, and so that mutex unlocks that number, and so then it's available to be locked by others. So what that means is this will only ever increment once, and the proper way, such that no one else has access to it at the same time. And then down here, this is just a way of finishing, waiting for all the threads to complete, and then we have to print out that counter. We have to lock it again, and then it can print out the result. And the beauty about this is that Rust will not allow you to do multi-threaded programming without mutexes, or without some kind of locking mechanism, or you cannot screw up data inside another thread by mistake, which is something which C++ or other languages just don't even consider. Yeah, so this is actually got a problem, and it gives you an error message, and then in this case it didn't like it. And what we actually need to do is, because we are creating mini threads, we have to wrap this counter around an atomic reference counter, because we're putting this counter actually into multiple threads, not just one. So what we need to do, an atomic reference counter, a reference counter is a way of accessing memory, and the atomic part kind of says only one person can access this memory at once. And so what you need to do in this particular case is wrap it inside an atomic reference counter. This example would have worked if we'd only had one thread, but because we cannot move the counter 10 times, we had to put it inside an atomic reference counter. Does anybody have any questions about that?
There are other types of reference counters as well.
Yeah, so there is just a reference counter. So a reference counter is more performant than an atomic one because you don't have to check that someone else has got access to it. And a reference counter is just the same as, I believe, how Swift and other languages which uses reference counting to manage the memory does it. So in a way, you kind of get to decide how you want to manage memory in Rust, if you use a reference counting or just the standard Rust way of managing memory. Does anybody have any questions about threads? No. A good reading thing to read is the Rust book, chapter 16. It goes through it quite well. I'm actually going to skip this one because I did this a year ago and it kind of doesn't make sense anymore. But there is actually some very good material, and I'll make this available. Is on YouTube, the history of async await in Rust. And this also talks about the green threads and the threading model and how it came to be where it is today. And then a good simple example which does better than what I'm doing here. So the other thing I wanted to show you about is macros. And macros, as C showed before, is a very powerful way to kind of enhance Rust or any language which has macros. So there are two types of macros. One is declarative macros, and the other one is procedural macros or proc macros. Declarative macros are the simpler version, and procedural macros are a whole nother programming language in itself, almost, and very, very powerful, and you can do some interesting things with them. So I'll go through the declarative macros and in a bit more detail, but I'll show you just some high-level examples of what's capable with proc macros. So in C, for example, you can create a macro. For example, it looks like a function, so we've defined something called min, which compares A and B and gives me the minimum value. The beauty about this macro is that you can use it for anything. So you can compare integers or floating point numbers. You could even compare strings, but the result would be kind of interesting, especially in C. And basically what the preprocessor does in C is it applies this min definition to here, and it essentially inserts this code into here. And so it will, in this case, it would be a hard-coded 5 is less than 2, question mark. And then it would actually probably compile it away to begin with, but that's what it does. So with Rust, I'll actually give you a live example of this. So what we'll do is we'll create a main function. And then we'll do the same kind of min example. Let x equals min a power 5, 2. So one thing with Rust, a macro is always defined by an exclamation mark at the end. So print line, for example, is a macro as well as Vic, but we're going to define our own min one. And then if you're doing it in the same file, so you do the macro roles, min, and then so what you can kind of see here is we're defining a macro called min, and then it asks for an expression. And it can have multiple expressions. So I'll show you an example of that shortly. So we'll do A, and that's an expression, and B has an expression as well. And we will actually, so we're actually going to return a block. And in that block, we're just going to say the equivalent of the C code, which is if $A is less than $B, then we return A, else we return B. And if we save that, we need $. So that should run. Sorry? Yeah, I suppose. Yep. Okay, let's see. So we got 2 in that case. This is all well and good, but if you want to, like, let's say you want to do 5, 2, 3, give me the minimum of all of them. You can see here I've got 3 of those. So you can actually, you can make this expression a bit more interesting by, you can have what's called kind of like a regular expression, almost. It'll be like this, I believe. But I won't do it that way. I'll show you the example of it. What we're going to do is we're going to match over the case of 3. So that's also an expression. So in this case, we can actually recursively call our min. It's kind of a budget way of doing it, but it works. So if we now put in a number here, which kind of makes sense, 42, it should print out negative 42 again. And just to make sure it's not taking the last value in that array. So that's just an example of a declarative macro. And so what it's doing is it's looking for, like, within the min macro, whenever you're calling min, it's looking here and it's saying, yeah, that matches this one here, and for the third one it matches that one. But you, like the print line one, you could have many. It's a macro which you can see. If you go here, you can see it has multiple arguments and it has that star. And actually, if you look at it, this is actually coming from the standard library. It's extremely simple, except that it does go into some gnarly things there. But it's pretty simple on how that works. I have to say I haven't done much with macro rules, except for the very basics. But they can get very powerful in what you can do with them. Does anybody have any questions so far? Yep.
Why would you use a macro over a function?
Yeah, that's a good question. So, I mean, in this case here, I can kind of like overload my macro. So in Rust, you can't really you can't easily overload something. But a good example is print line statement. It takes multiple inputs. So a function in Rust will only take the specified number of inputs which you've provided it, whereas a macro will take, you can program it such that you have multiple, any number. And they're quite a bit more generic than just a normal function. Yeah.
One question I have is, so you can be able to do greater than, less than, types will be partial equals instance, or you need to have one of those traits on normally. So my question is basically, how is it making sure that you've got the right trait in place to allow comparison like that?
Yeah, so my understanding is it understands, like, it's just doing code substitution, and it kind of understands what code you're trying to substitute. And it does it reasonably well. So what I will do, I'm just going to take out this print line statement here, and then clear this one. And what was it? Cargo expand. So if you cargo install expand, I've already got it. So when you're developing a macro, extend.
Cargo expand.
That's right. Cargo expand. There you go. It's already installed here. So what that means is I can go here, cargo expand, and you can actually see it's taken my code. You can see what the preprocessor in the Rust compiler has done. Although I don't think the Rust compiler has a preprocessor, but the C equivalent has taken this code here and expanded it out such that I've got all of my ifs like that. And that's essentially what the macros are doing. You're abusing your code.
Question about macros.
Yeah.
So when should you go for the macro and when should you go for the functions?
I'd say avoid the macros if you can. But if the macros make your life easier, use them.
So for development tools, like things you would use on your local development to make your life easier, like print line or whatever.
Yeah.
Stuff like that. Okay.
Yeah. So I mean, print line is a good example of where you want any number of parameters. You know, like you don't want to have print line 1, which can only take 1 argument, or print line 2, which can only take 2 arguments. So that's one example of how a macro would help you. I mean, another good example is vec. Vec will take any number of arguments as well. And the interesting thing about macros is that you can, that's a valid Okay, in the case of Vec, you can see my Rust format has changed it, but you can actually put your macros inside of curly braces. Or when you call a macro, you can put it in the arguments inside of the curly braces. Which is kind of strange of how Rust actually does that.
What's the purpose of curly braces?
Yeah, I don't know. I think it's some people like a different code style, and so I'll show you an example shortly. So in terms of proc macros, there are 3 types of proc macros: derived macros, function-like macros, and another not declarative, attribute macros. And in this particular case, we have the struct point has the debug derived macro being applied to it. So what that means is some of this code is being generated on the point struct. And I think actually a better example is, I'm just going to copy this code here, put it in here. So what we have here is we have a point struct, and we create a point with 2 points in it, an x and a y, and we'll run it, and it prints out point x1, x minus 1, and y 42. But what we can do is we can derive the debug macro, and then we can get rid of a lot of this boilerplate. So what this is now done is it's actually derived, generated some code for me, and you can actually see it actually prints it out neater than my code, and that has created some special formatting instructions code. And what you can see here is what it did for the point structure. It created this, it implemented debug for point, and then there's a format function in there, and it formatted the way we expected that to format. The thing about the derived function is that recursively all the structures inside of point also need to, all the types also need to derive debug as well. And so it's the same with copy and clone and anything like that. So what you see is a lot of powerful crates like Serde. They come with you can add a lot of code to a structure, and so you can get rid of a lot of boilerplate code. It's extremely powerful. Any questions so far? And then, I mean, then you almost get to the abuse of what you can do with Rust code. So this here is actually valid Rust code. So here we've got the view function. It returns HTML, which will be some type of structure or trait. And here we've got an HTML macro. It will be a proc macro most likely. And inside of there we've actually got HTML. So we've written HTML. And inside of that we've got some Rust code. So it's kind of like going back into the world of PHP or what's that, JavaScript, JSX. But it's quite interesting to see what people are creating from procedural macros. And I've seen people create Java, simple Java programs, so you can write Java inside of Rust. Yeah, I don't know. I think it was more for entertainment than anything else. And it wasn't proper Java, but it was pretty close to it. And so this comes from a web framework called U, and so you can actually run Rust, like it's kind of the React for the front end. So there's a very good, the Rust reference book has good examples about macros. Very good video is Crust of Rust, declarative macros. So the guy just goes through like how to structure macros, especially declarative macros, and the little book of Rust macros goes into the details of macros in Rust. So does anybody have any questions about what we've presented tonight? All right, that's it from me for now. Do you want to present your thing? I don't know, Amy's got something for show and tell, so we'll quickly do something there.
Hi everyone. It's awesome to meet with such a group of passionate people about programming and Rust. So yeah, I thought I'd introduce myself. I'm a programmer who's been coding in C++ for 7 years, although I look a bit young. Well, I did 5 years in audio software and 2 years in AI. Now has just moved in to Centrality as a community developer. So I thought I'd show what I've been working on as a personal project first, which has nothing to do with Rust. But then I'll talk a little about how you can use Rust to build some applications that work with blockchain, which has something to do with Rust. So yeah, so since it's show and tell, so I'll show my personal project first. So I built this music learning app over about 3 years. Sorry, can't type with the microphone. Yeah, I built it with C++ actually. Yeah, it's a music player that lets you slow down music and learn by ear. It's a productivity tool for you to learn any instrument. So slow down and repeat a section, learn section by section. Picture of me. Maybe I wouldn't play the video anymore, but basically it just introduces the software. So the idea of telling you guys about this is that I'm a solopreneur, so I'm a programmer and I did a UI design course. I did a UI design for the software, built a website. And now my new role at Centrality is to help creating a community of developers who build decentralized apps. So that's why my role is called a community developer. So what exactly do I do? I help, so at Centrality they make this platform for building decentralized app called SenseNet, which is built in Rust in New Zealand, which is pretty cool. And it's based on this framework called Substrate, which is also written in Rust, but the Substrate framework's idea is to connect different blockchains together and read information from different blockchains, whereas SenseNet's intention is to provide a framework for people to build apps more easily. So they have this API that's in JavaScript, and you can write your front end in JavaScript, any framework you like, and it communicates with the blockchain and uses the blockchain as storage. So to write transactions, you need to write your code in Rust to say what kind of information you want to store and then read it back. So it's like a different form of data storage. So my role will be creating sample code and documentation and generally helping out if anyone runs into trouble. Yeah, so hopefully people, if you guys are interested, chat on Slack. I'll be on the Rust channel.